Hi everybody. Today I want to talk to you a little bit about polynomial inequalities and how we can go about solving them. We're going to learn something called a sign chart. Okay, so I took and wrote up here before I joined you different inequalities. So we have like greater than or equal to, less than or equal to. Okay, so a typical question here could be find where our polynomial is 0, positive, or negative. Okay, and for our example today, let's say f of x equals, and I've already factored this one, x plus 3, the quantity, times the quantity x squared plus 1, times the quantity x minus 4 squared. Okay, so can you tell me a little bit about this f of x? Well, what do we know? First thing, you can identify the zeros for this polynomial. So at this point, we know that x equals negative 3. X squared plus 1 doesn't have any zeros, and we also have, for x minus 4, the 0 would be 4. We can even mention multiplicity. Here is 2. The multiplicity of our negative 3 is just 1. Okay, so if we think even a little bit further, let's talk about the degree of our polynomial while we're right here. Okay, so we have, let's see here, a 1, 2, 3, 4, 5. Okay, so our degree is odd. We also notice that the leading coefficient out here is 1, and it is a positive 1. So at this point, we are positive odd. So we know our general shape is something where the end behaviors were going to negative infinity and positive infinity. Okay, so let's take a look here. If we think about our graph, okay, or a number line, I'm sorry, not our graph. Okay, we have a 0 here at negative 3. We have a 0 at 4. Okay, so as far as we know, and I'm just kind of sketching this off a number line, just doing something real quick here. Okay, so what we know is that we have a basic shape like this, okay? If our multiplicity is odd, we are going to pass through the 0, okay, or cross the 0. Multiplicity is even, we should touch and go, okay? So we have in our mind a little bit of a graph that looks like this, okay? So now how does the sign chart play into this? Well, for those sections that I've created between the zeros. Okay, let me get this out of here. I'm just put that in to kind of say, okay, this is what we're thinking. All right, so let me get this back. All right, so from negative infinity to negative 3, I want us to take a look at our function in terms of are the values positive, negative, or positive or negative. So like, let's pretend I like negative 5. And I'm just picking something out here, whatever. And I put negative 5 in here for all the x values. I don't care the value, I just want to know the sign. Is it positive or negative? So like here, negative 5 and 3, well that's going to be negative. Negative squared is positive plus 1 is positive. A negative 5 minus 4, and then you square it, is going to be a positive. So what's that mean? A negative times a positive is going to be negative. Okay, so next we'll go in between, well I could have left that there, negative 3 and negative 4, or positive 4. So like 0. So if I take these three quantities once again, and I'm thinking about putting in a 0. And again, I don't care what the values are, I just want to know if they're plus or minus. So like here, 0 and 3 is positive, positive, something squared is always positive, so in this zone, we're positive, and over here was negative. All right, lastly, between 4 and infinity, okay? So same deal, I don't care, pick something out here. Okay, 5. So like 5 plus 3, 5 squared plus 1, 5 minus 4, the quantity squared. Well, 5 and 3 is positive, 5 squared plus 1 is positive, and whatever squared is positive. So down here, we are also positive. So in thinking back to the quick sketch I made at the beginning, from degree 5 we were positive odd, we in fact said down here is negative, we cross, we come down here and touch, and we go the other way. So were we right? Well, negative here, positive between, positive down here. Okay, so how would I answer my question as far as 0, positive, or negative? Okay, so the zeros we answered, we were negative 3 and 4. Okay, so if f of x is greater than 0, so positive, okay, so where? Well, from negative 3 to 4, so negative 3 to 4, and also 4 to infinity. And I did not bracket these values because I just said strictly greater than, okay? We can next say where f of x is less than 0. So where is f of x negative? Okay, well, down here, so we would say from negative infinity to negative 3, okay? If I put on here, where is f of x less than or equal 0? All right, well, if I put that equal to 0 in there, how will that change your answer? Well, at that point, you would put the bracket in because then we'd want to include the negative 3 as a 0 because of the equal. And I could make a similar statement for the greater than. Okay? All right, questions? Oh, wait, I can't hear you anyway. All right, so that's working with a sign chart to identify where a polynomial is 0, positive, or negative. Also tying in what we know about odd degrees, in behavior shapes, okay, and what it's going to look like all together there. If you want to stick around, I can show you a second example. Okay. This out of the way. Maybe we'll. Okay. So maybe same sort of question. Let's start with a new f of x. Maybe something like f of x equals x plus 3 times a quantity x minus 1 times a quantity x minus 4. Okay? And same question. Where's the polynomial 0, positive, or negative? Okay, so let's start first. Where is f of x 0? Okay, so zeros. Well, we have 3 of them. Looks like here, negative 3, positive 1, positive 4. Okay, so we have 3 zeros on our list. So, yeah, I can come over here this time. So if I mark those on here, we're at negative 3, 1, 4. And I'm spreading that out a little bit so I have some room to do some calculation. Okay, so we want to explore this a little bit. So let's think of this, x plus 3, x minus 1, x minus 4. So in the first region, from negative infinity to negative 3, we need to take a look at a value. Okay, how about negative 5 again? So if I put negative 5 in for all the x's, let's think, are we positive or negative in the answer? So here, negative 5 and 3 is negative. Negative 5 minus 1 is negative. Negative 5 minus 4, still negative. So a negative and negative is positive times a negative is a negative on the left. Okay, so let's go in the middle here. So x plus 3, x minus 1, x minus 4. And there's no law that says you have to write these every time. I'm doing it because I'm trying to show you your first time and it's your notes. Okay, so from negative 3 to 1, how about a 0? Okay, 0 can be our friend. So 0 and 3 is positive, 0 minus 1 is negative, 0 minus 4 is negative. So positive, negative, negative makes a positive. Okay, all right, next up, from 1 to 4. Okay, maybe pick 3. All right, so again, 3 plus 3, 3 minus 1, 3 minus 4. So we have a positive, and a negative. So that means that's going to be your right, negative. And lastly, from 4 to infinity. Okay, I'll pick my 5 again just because I like 5s. So 5 plus 3, 5 minus 1, 5 minus 4. So we have a positive and a positive and a positive. Well, that must be positive, okay? So how does that work out as far as our leading coefficients and all these other little rules we know? Well, my leading coefficient up here is a 1, and it's positive, okay? What do we know about our degree? Well, 1, 2, 3. So we have a degree 3, which is odd, and positive. So in our thinking, we should have odd, positive, something like that. So the end behaviors, negative infinity this way, positive infinity this way, okay? What else do we know? Well, on the zeros, okay, all of these have a multiplicity of 1. So multiplicity of 1 implies that we are going to cross the axis at the zeros. So if you think of that, this basic shape should start down here. Okay, so I'm going to my 0, I'm going to cross. I come back to the next 0, I'm going to cross. To the next 0, I'm going to cross. Oops, and I missed. Make that bigger, and it keeps going. Okay, so how does that fit our sign chart? Did we figure the positive and negatives correctly? Well, look here. We have a negative, positive, this section negative, this section positive. It sure looks like we have that correct. Okay, so to finish answering the questions, we have the zeros. It asks next, when is the function positive? Okay, well, we are positive from -3 to 1, and also from 4 to infinity. Okay, so we're positive up, and then lastly, where is our function negative? Okay, so this was positive, this is negative. Okay, so where are we below? Well, from negative infinity to -3, and also from 1 to 4. So negative here and negative here. Okay, I'm using all parentheses because in my inequality I did not say equal to 0. So I do not want to include the zeros in my answer on the intervals. Okay, so once again, that was a nice example of using a sign chart to find an inequality. Okay, I think at this point maybe we'll stop. I don't know how long our video is. 13 minutes, yeah, maybe we'll stop. I'll have a part 2 coming up. Thanks so much for watching. See you next time.